The BritChips podcast is proudly sponsored by Silicon Catalyst UK.
We are the Metasurface nerds, Yash and myself. Well, we can
That's a great strap line. We might use it yet.
we can talk about Metasurface for hours and days.
Hello, I'm Anthony Miller and welcome to the BritChips podcast, where I have conversations with movers and shakers in the UK semiconductor startup scene. Now, my guest today was born in Paris, though spent his very early years in Tokyo. As a student, he moved to Singapore for his PhD and then on to Texas via Edinburgh for his first postdoctoral position and then on to Glasgow for his second. Now, I'll leave it to him to explain how, in amongst all that travelling, he got to meet a scientist by the name of Yash Shah, who was eventually to join him in launching a startup. So, to tell you about that and the rest of the story, let me introduce Charles Altazura, co-founder and CEO of imaging technology startup Metahelios. Charles, welcome to the BritChips podcast.
Thank you, Anthony. It's great to be here.
Great to have you here. So, Charles, the first question has to be, why did you call your startup Metahelios?
We hadn't had the experience of really naming any company before, but we were thinking of something along the lines of Meta before Facebook became Meta. Right at the time when we thought, oh, that's a great name, then we heard that Facebook rebranded to Meta. So we tried to find other versions of Meta and something else. And we're thinking Metahelios, Helios for light or the Greek god.
The sun or something to do with the sun, isn't it?
Yeah. So we just went with that and we're like, okay, well, that seems like a good name. So let's just go with that. The Meta was the important part for Metasurfaces, but yeah.
Yeah, which we will get into. So, but maybe it's best to start, go back to the beginning. I mentioned your co-founder, Yash Shah. So tell us, how was it that you originally met up with Yash?
See, I had done a short stint where I was collaborating on work in Edinburgh at Heriot-Watt University that had to do with quantum optics and metasurfaces. And then I left to go to Texas. And while I left, the group where I was previously wanted to continue on this work and hired Yash in part for that, but also to conduct other projects. And so when I went to Glasgow, we met Yash and myself. We were the two only experts of metasurfaces in the group. And it really created a really strong friendship. Even before that, we were best friends. It was really it was really great. We really met by exchanging ideas about metasurfaces.
And as a result, Metahelios is your love child.
Exactly. It really is. Yeah, absolutely.
So it sounds like, you two guys were perhaps some of the very few who are looking at this whole metasurface thing in this particular way. But what actually prompted you to, create a startup? What was it you were trying to develop at that time?
So Yash he was continuing some of my work, which is different than the technology that our company is based off of. That is something that he has pioneered along with other scientists on the seminal paper that came out in 2019 in Optica that had to do with this metasurface pixel technology. And so really, what prompted us to create this company is that we noticed it was harder and harder to find funding. And we just didn't find the situation in academia to be particularly sustainable for the kind of the hopes that we had for this scientific topic that we were interested in.
And what were those hopes? What was it that you were trying to get to and indeed the very reason you launched Metahelios?
Yash had come up with or was an expert and had pioneered this technology which would completely substitute this particular technology called color filter arrays. And so really our hopes was to really go fast with this. We wanted to really focus on it. And we really felt like a commercial path was probably the best path for us than an academic one.
So just to explain as much for the audience and myself, these color filter arrays, these are things that are used in optical imaging equipment and like cameras. I mean,
Yeah.
what was wrong with them? Why did you think you could develop something better?
So, really at the dawn of digital cameras in the end of sort of the 90s, they were developing these digital cameras which needed to capture color. Now you have kind of like two crucial parts in a pixel technology. You have the photodiodes that just detect intensity of light. And you have these color filters, which are different colors. And by post-processing, you can reconstruct any color. And so effectively, it really creates images that are in color in the end.
And typically those filters are like, the red, blue, green primary colors, which then can be sort of blended to whatever color you like.
Exactly. And so this technology is, big companies that are manufacturing this technology are like Fujifilm and Toban, who have, billion-dollar factories that chemically manufacture the material which is made out of pigments or dyes. And so really the problem with this is that it hasn't really evolved, this technology, because it's very difficult to make this technology better. And so that's where our technology comes in, is that we're providing means which circumvents all this complex chemical manufacturing. Our technology is made out of very thin aluminum with nanostructures, which uses equipment in foundries which are already used for manufacturing pixels. So it's really not anything different or exotic.
Hang on a second. So what you're saying is you are developing a replacement for these filter arrays, if you want to call them that, which is aluminium foil?
Yeah, it's made of aluminum. Yeah, which aluminum foil is made out of as well. Yeah, absolutely.
Okay, well, it's great if you want to cook a turkey as well. But tell me, so your aluminium, as we say over here, filter thing doesn't actually have like red, blue, green filters in it. How does it work?
That's a very good question. The secret is in our nanostructure design. So nanostructures are very small holes or structures in a material that can create very specific resonances. And therefore we can absorb and transmit particular bands of light, which allows us to create these filters.
Wow. I mean, that is really quite significantly
Yeah.
different. And where did you see the initial uses for your technology then?
We've had a very interesting journey from starting the company. We first started really in defense and space. That's where our first demand for our technology was, where we made a bit more than £250,000. And we were being subcontracted by defense entities and space entities.
And these for what? Some specialized type of camera for, well, seeing distant objects or something?
Yeah, so I can't specifically talk about because it's protected under.
No, yeah, otherwise you'll have to kill me. I understand.
Yeah. But yeah, is ultimately there was interest for visible wavelengths, but also mostly for shortwave infrared wavelengths. And it was really to create these filters to provide more information about the environment, about surroundings.
And what you obviously made it work, but you didn't follow that path any further, or what happened next?
Yes, it became something quite difficult to sustain once we tried to fundraise. 2023, we tried to fundraise, and a lot of VCs were not open to defense or dual use at that time. It was really not quote unquote sexy. So it was very, very difficult. And so we did have to slightly pivot away from that, even though really the core of our technology to start with, the first commercial traction we got was really for defense and space. So we had to slightly pivot, and instead of going for institutional investors, we did a friends and family round.
Okay, so that sort of kept you sustained, but you said you did a pivot. So the pivot wasn't just on the funding; it was on the product as well.
There was a lot of interest. We were sought out by a lot of smartphone companies that were very interested in our technology. Smartphones and the sales of smartphones as a direct correlation to the quality of the images for cameras. So the better the camera, the more traction a particular smartphone will have. But that's a very difficult market to enter. We instead, as a beachhead, are looking more into robotics and automotive. That's really where high demand exists for a particular technology that we develop. which fits more under the criteria of physical AI.
Okay, so that was a pretty momentous pivot then. I mean, so you didn't even try to approach the mobile phone market, or you gave a tilt at it, and it was just you just found it too hard.
Gave it a try.
Mm.
Yeah, we gave it a try, and we noticed that it's very difficult
Yeah.
a lot of conversations and a lot of
Mm.
um, yeah, it's very difficult.
So, as you say, edge AI, robotics, autonomous vehicles. How did you pick and choose where to start with those use cases?
It was really a journey to really figure out, a lot of research and a lot of trying to understand specific things. What we found very difficult, and I think we still do find it very difficult, is that for these very large markets, and particularly in the image sensor industry, there's a lot of things that are very confidential. And so you
Yeah.
kind of have to go to these conferences, trade shows, have conversations, and sort of iterate from those conversations. How are they doing this? And what is the real genuine problem? Because large companies will not want to, of course, highlight what the problem with their technology is. So they will say, no, it does this. And then after more conversations, you're like, oh, actually, it doesn't do that at all. Or it uses an immense of power to establish this, or to a lot of post-processing to get these images. So it really takes a lot of, poking around and figuring out, and so for the robotics industry, what we found out is that, and it's the same thing for the automotive industry, but for different reasons, is that you need to be able to capture color with high accuracy, because that allows you to be able to sort of, for an autonomous systems, to recognize objects and features in the real world. But also they need near infrared light, which is important to see in very low illumination conditions, or to see for depth sensing. And that's an avenue where we could provide much more enhanced quality.
So the sort of robotics and autonomous vehicles that are in use today, but they're using, I guess, what you might call traditional sensors with the typical red, blue, green filters that we spoke about earlier on. And is that where they are now in the technology development?
Yeah, so there are these image sensors that are called RGB near IR image sensors, where they try to,
RGB, sorry, say RGB. Oh, I'm sorry,
or
what was the rest of it?
RGB near NIR, so for near
Oh,
infrared.
infrared. Got
That's
it.
right. It is an image sensor that was really meant for autonomous systems, in order to, instead of using two cameras, have something much more bulky, needing to do like complicated image fusion, etc. You try to have everything in one image sensor. So you reduce the fusion of images that you do in post-processing, where you can have misalignment errors or anything like that. And it creates a much more compact module, which of course is very important for robotics. And so what we recognize is that there was an issue with these image sensors, because infrared light leaked into the red, green, and blue channels. And so it can't capture images in every illumination condition. And our tech
Yeah, that sort of full spectrum you're saying as you say, in varying illumination
That's right.
conditions.
That's
Get
right.
it.
So our technology
Yeah.
is really breakthrough, because if you can't have, for instance, a robot that can operate in every illumination condition, it's not autonomy. It's essentially, okay, well, I can only put the robot in this particular situation, and in this particular environment with this particular illumination, and it can't go anywhere else, right?
Yeah, and also you don't want a car that you can only drive in daylight hours.
Exactly. Exactly. So that's the right way to put it. Yeah. So that becomes effectively a problem. That's where our technology is really imperative, is specifically for autonomous.
So you kind of pitch up to I don't know whether it's the robot makers or the EV makers. Or actually, the question should be: have you yet pitched up to them and said, "We've got something better. Would you like to give it a whirl?"
We are speaking with very large end users. Our business strategy is that we license to image sensor manufacturers. We license our technology designs. So our direct customers
Oh.
are the image sensor manufacturers.
And these, you may not be able to name names, but these would be the traditional large scale image
Yeah.
sensors, of which the ones you make for
The
cameras and all sorts of things. Yeah,
exactly. Like
yeah.
we've
I mean, you can mention names if you
it,
like.
we it's I feel like they prefer not for us to mention their names, but what I can say is that we are speaking to every image sensor manufacturer for the consumer market.
Mm, are they showing enough interest to ask you to sort of trial the technology, I guess you'd say?
Yeah, yeah, I I I would definitely say so. For a few names, they've been in touch with us for quite a bit of time. So they have particularly Asian. I find that Asian companies are really good at identifying early on. The Western companies are a little bit European or American, a bit. Well, American not so much, but European companies a bit later stage. Yes.
So where does that take you with these companies? Is there a point at which they say, okay, we would like to trial the technology. Can you create a prototype or whatever? I mean, what are the steps which will basically get them to sign on the dotted line and buy something?
I mean, they need to see that commercial traction. They need to really understand, and that's why we're knocking on both sides of the door. The first time that I heard that expression was during a talk that Tudor Brown, one of the co-founders of ARM, gave. And
So you talk about the term knocking on both sides of the door?
yeah, exactly.
Yeah, because I was going to ask you exactly what that meant in
So
practice.
it's speaking to our direct customers and speaking to the end users. Yeah.
Uh,
Yeah.
to get the demand pull for yeah,
Exactly, because we need to understand what their customers want. So
yeah.
so so the best thing for us to do is that we don't just speak to them. That would be a mistake. We don't just speak to our direct customers. We speak to their customers as well in order to understand.
And they, of course, introduce you to their customers, I assume, because it's in their interest to do so.
Yeah, yeah. In some cases, they've been quite
They
open
do.
to do so. We also explore it ourselves. We also have our own
Yeah.
contacts, which has been
Mm.
helpful, and we're also aware of that. Our customers have very busy schedules, and so we know that they can't be available for us 24/7.
So when do you think you'd be in a position to have a trial with one of the sensor manufacturers of your technology?
It takes quite a bit of time because we need to probably conduct some R&D into integrating our technology into their supply chain.
Into their
Yeah,
sensors? Oh, into their supply chain. Oh, yes, yes,
yeah.
yes,
So
yes.
so
Oh,
so that's so that can take a bit of time. I would say that from the moment you start, and also they're very busy, of course, with their manufacturing schedule for other products. So it really depends because it depends when that window is, how long the R&D
hmm.
going to take, etc. But I would say generally it's about 1 or 2 years from the moment that you start looking at their schedule, the manufacturing schedule, etc. The moment it's wafer manufactured, and then afterwards it will have sort of integrated into a device. Yeah.
Where are you now in getting someone to commit to start that journey with you, would you say?
So we're still developing and improving our designs, and but it's
Okay.
actually a lot more in terms of the full characterization, conducting all the tests for our technology, etc. That is taking a bit more time, specifically with our quite small
Mm.
team at the moment. Of course, as we grow, it will be much faster. The technology has already been demonstrated in camera modules, so that's not an issue. It's been published on, and also by Yash,
Oh,
and also we've got
mm,
revenue from integrating our technology into camera modules. But it's still that, really to provide that convincing case to both our
yeah.
customers and our customers' customers.
It's a long journey, I understand. You've got the technology, as you say, in camera modules in certain use cases, certain applications. Where are your, well, Metasurface things actually being manufactured?
So we manufacture, we do all of our R&D at the University of Manchester's National Graphene Institute, which is absolutely wonderful. Great facilities, great people, and it's been absolutely great to do it there. So that's where we manufacture our technology for low rate, of course, and it's mostly for R&D, or if there's particular modules that we need to integrate our technology in.
You and Yash are in Glasgow. So what you have to, I don't even know what the motorway is, but you have to
Yeah, no, it's been
yeah, hike your carcass down the road, so to speak, to Manchester every time you want to do a test.
Yeah, so
Mm.
so so we noticed that conducting our R&D and fabrication in Glasgow was a bit too costly. So we
Okay.
actually decided as a business decision to manufacture. So for a long time, Yash was actually, yeah, he was doing backs and forths from Glasgow to Manchester. He's he's definitely done way more than his part for this company in terms of that. It's been exhausting. Trains canceled, trains delayed, but now he's permanently in Manchester at the moment. So
Okay,
yeah,
right.
yeah,
That makes sense. So you're based in Glasgow. He's based in Manchester, and
that's good.
obviously the technology helps you communicate with each other.
Yeah, it's unfortunate. We know that at some point we're going to be in the same place, but it was the best way to proceed, and just this constant back and forth. It just can't
No.
work.
You were talking about funding before, and you mentioned that you were relying on family and friends to get you thus far, but clearly you've got a huge development journey ahead of you. What would you say would be the next significant milestone for you and Ash and the team, and what extra funding do you think you would need to get you there?
So we're actually fundraising right now, approximately £4.5 million for our seed round, and that will get us really to the point where we're the commercial ready position. And so it will really take us to a point where we can license freely and just with the best optimal design.
And have you got VCs sort of interested? Where are you along that funding journey?
Yeah, we've been speaking to a lot of VCs. I think that fundraising right now is not easy. It's quite difficult times. We're also encountering these differences in between, how American VCs invest and how UK VCs invest. There's difference of culture there, but it's been positive. We built out quite a bit of traction last year by being members of these very selective accelerators, which
Yeah, I will come. Definitely want to talk about that. But yeah,
yeah, so which include NATO's accelerator, NATO Diana, Silicon Catalyst, and Next Core Illuminate. And meanwhile, we've also gotten several grants, which includes the Innovate UK grant. And so we that sort of level of selection for our company has been very helpful in terms of making this real.
and when would you hope to close the round?
We're hoping to close it by end of July. Um,
Oh
so
wow, okay, a couple of
yeah,
months.
yeah,
Yeah.
yeah, yeah, absolutely. So we're
Hmm.
we're in advanced talks with quite a few VCs at the moment, and hopefully we can close it in time. But we do have a safety net in case we don't close it in time. So that's fine.
You have a safety mat. Did you
Yeah, yeah,
say?
yeah, yeah. So we have means to sort of extend. We have enough runway in
Oh,
order to take us
okay,
a bit further.
okay. You don't have to do a bank job or anything like that.
No, 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 no. Sorry about that. Yeah, that's generally an expression you'd use for that. No, it's yeah. No, what I mean is that if we haven't raised by end of July, we're not completely underwater. So
Do you think your raise will include any UK VCs?
hopefully, yeah, hopefully, yeah.
That would be great. Mm,
Yeah, we are speaking to a lot of UK VCs right now.
mm.
So I think upwards of about 10 right now. So it's
Oh,
yeah,
great.
yeah, yeah. So there is a good amount of interest in our technology in our company from UK VCs.
Mm.
And I really hope so because I think that our technology can create unique sovereignty for the UK in terms of image sensor technology, and I really would like for UK investors to be involved in this seed round.
And they get it. They get not only what you're trying to do, but they understand, at least at a superficial level, like me, how you're doing it. I mean, obviously, I don't understand
Mm.
exactly, the structure of the aluminium foil, but they understand that this is revolutionary stuff and be really transformative for the industry.
Yeah, no, absolutely. I mean, this is something that have by the way, has already gained traction. There's already proof of very
Yeah.
large image sensor manufacturers already mass commercializing a much lower performance of our technology, which of course now would be very hard for them to operate because now that our patents have been accepted, it'd be very hard. But it's a reality. It's a reality that the image sensor
Yeah.
industry is moving in this direction. The only company that can provide this technology is based in the UK. It's Metahelios. There's no other company. So that's really the main point.
That's fantastic. And the patent was a really important point, the fact that you got the patents on this so that you are, it does protect your IP, which is obviously absolutely essential. Because I would imagine all the sensor manufacturers would be trying perhaps to develop the same thing, but hopefully you've got them cornered.
Yeah, no, absolutely. I mean, we are the Metasurface nerds, Yash and myself. So, we could,
that's a great strap line. We might use it yet.
We can talk about Metasurfaces for hours and days. As the UK government often talks about, hey, we want to create this, sort of Silicon Valley, et cetera. Well, Silicon Valley started with silicon semiconductors. So we're sort of going back to basics with our technology in terms of
that's a good point. The clue is in the name. Do you know? I hadn't thought of that before, but absolutely right. Now, you mentioned before some incubators, accelerators, ChipStart, Illuminate, and NATO Diana. And it's interesting because I talk to many entrepreneurs like yourself who go through a number of different incubators and accelerators. So I'm kind of assuming that they each give you something different. It's not like you can go to one incubator accelerator that can take you on the whole journey. In outline, what did you feel you get from each? Because I think we originally met through ChipStart, and I'm a keen supporter of, this is the government, UK government incubator. What did you in outline get from each that sort of took you further along the journey?
I think it's really important to state as well for people who are going to watch this podcast and understand what each accelerator brings from the perspective of somebody who has participated in these accelerators. That was a main point for us when we were thinking, okay, which accelerators do we want to be part of? Because we want them to bring something unique and something that we really need. So if I start with Silicon Catalyst, Silicon Catalyst was really, really great in order for us to really focus and narrow down exactly the market that we're going to be targeting. And really understanding we can't do everything. This is a big problem with a lot of companies and a lot of deep tech companies. It's like, we can do our technology for all of these different applications. And really Silicon Catalyst helped us with that, but also helped us with putting us in touch with a lot of people in the UK who are semiconductor experts and who have been able to provide invaluable information about both the UK ecosystem and really in-depth understanding on particular technologies.
Yeah, I should just explain for the audience in case they weren't aware. Silicon Catalyst is the organization which is actually responsible for managing the ChipStart program. So it sounds like they were instrumental in your pivot into sort of robotics and autonomous vehicles. Then it was the business and commercial and market aspects.
Yeah. So it really kind of took us, and they really supported us, and you get a mentor, and you get to have frequent conversations with that mentor, and to really kind of bounce ideas off of each other. And so that was really helpful. And that was really the stage where we're moving slightly away from the defense angle as well. And, they take you a little bit in different places in the UK and get to meet different people in different areas. In Cambridge, we were at the ARM offices. It was a wonderful experience. It's just really great. Yeah.
And you were part of the second cohort, and obviously that program has long since finished, but you're still, they're still kind of looking after you, so to speak, even that. Yeah.
I just sent an email to Sean 2 days ago. Yeah.
Sean Redmond being the leader. Yeah. And what about now NATO Diana, which I hadn't heard of before we had our first conversation, that I assume is the defense related sort of introductions and the like?
Yeah. So NATO Diana is an accelerator that gives approximately 100,000 euros to each company that gets accepted. They have about a 7% acceptance rate. And so it's also highly selective, but it is purely for defense purposes.
When did you go through that program?
It was towards the end of Silicon Catalyst. I think
it was after ChipStart.
That's right.
Yeah, towards the end of ChipStart.
That's right. Yeah. yeah. We actually had sometimes to coordinate the traveling we had to do for Chipstart UK and the travel we had to do for NATO's, like going to Poland and then going to Cambridge. So what NATO Diana really brought to us is really a lot more awareness of how the defense sector works and rebuilding relationships and a network for Metahelios in the defense industry. So that was really important. And so we were based at the accelerator site in London, which was
Right.
great, and it also allowed us to interact with unique high placed people in the defense sector in the UK. Yeah.
And again, that program has finished, but you're still in touch, or
Yeah, absolutely. Yeah, they're very good about
yeah.
staying in touch and staying up to date. And also part of being part of this accelerator, which was wonderful, is that they create. It's quite good for our marketing because we were featured in articles and etc. So it really creates awareness of our company
Mm,
and in
mm,
in very well known outlets. So
mm,
that was very
mm,
positive for us
mm.
as well. Yeah.
I hope this podcast will get your company well known in other outlets as well, but that is to be seen. So where did Luminate fit in then?
So Luminate, we were really interested in Luminate because Luminate, they're very centered. They do a lot of different things, but one thing that they're very centered on is preparing the due diligence folder, which is incredibly important for raising money. And it's something that if you have no experience, if you haven't raised before or started a business before, it's actually quite
Yeah.
intimidating because here we are, two scientists, Yash and myself, and we're like, God, what is this due diligence thing? Oh my God, this is supposed to be 7 pages. What? And what do we put in here? And so being part of that accelerator really sets you in because they have sessions that are specific to different files and documents you're supposed to have in your due diligence.
And was that applicable both to raising funds in the US and in the UK?
Yeah, yeah. The mentors and the staff there have experience actually both in the UK and the United States. So
Right.
that has been very helpful. NextCore Illuminate is also quite close to Silicon Catalyst. So yeah,
Okay.
they do communicate quite a bit from my understanding. But yeah, and it was really great for us. It was really great because Rochester, so you as part of Illuminate, you travel to Rochester,
That's New York
New
State,
York
is it?
State,
And
exactly.
Rochester?
Yeah, yeah,
Yeah,
yeah,
yeah.
yeah. Which is the where Kodak was,
Oh, of course,
and
of course.
so
The home of imaging.
yeah,
Yeah.
yeah, and it's absolutely wonderful because you have this pioneering expertise in imaging, and as a matter of fact, we found someone there who is one of our consultants now, who is extraordinary, who has had an extensive experience in in the sensor sector, and so it really allowed us to tap into that. And so that was really important for us, and it's really allowed us to
Mm.
advance our work to have some folks that are obviously have that expertise, which is very difficult to find in the UK. But obviously in that area, since they're all ex Kodak or all of these kind of like photonics, big time photonics companies were based in Rochester. So
Did you try and recruit him?
no, 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 no. Anyways, we don't have the money right now to be able to do that. No.
I guess so. But it's more than just you and Yash now, isn't it?
Yeah, so we have an employee in Manchester. His name is Rob, extraordinary expert of etching, also extraordinary guy.
And as you say, hopefully, as the funding comes through, you'll be able to expand the team too.
That's right.
Yeah, yeah. I always like to give our guests the opportunity to spread the wisdom of their experience to people coming up behind them. And, the first thing I usually ask is sort of knowing what you know now, would you have done anything differently when you launched Metahelios?
Yeah, yeah. There are a few things probably I would have done different.
Well, what are the most
Uh,
important ones, do you reckon?
I think a really important one is that, particularly if you're a scientist in academia and you're thinking of starting a company, reach out before you do that. Reach out to sort of people who have had that experience. And because, we kind of learned a bit the hard way, the amount of market research that you need to do, preparations for doing very specific things, preparations for meetings with companies, etc. There's a lot of kind of small things, some also quite big things that are important to kind of, and so it wasn't, obviously, we're still doing very well, but it was at the beginning a lot of work, and work that could have been made easier by having folks that would be helping you say, oh, no, the way you're supposed to, it's like this or it's like that. That's something that I might do differently, is get a bit more information on what are the initial steps that you're supposed to go through before you decide, hey, we're going to start this company.
Okay, so actually that's an interesting one, because I was going to say, does that mean you would have wanted to join an incubator like ChipStart earlier? But it sounds like it was even at the university stage. Were they not able to provide this advice to you in those early stages, would you say?
So we started the company when both Yash and myself had left the university.
Oh, you'd already left. Okay.
Yeah. So one of the reasons why we decided to leave the university is again, it was this big sort of like funding hole and issue, which and we really believe that maybe this would have been better outside of a university, more of a commercial opportunity. We still were able to obtain a lot of help, which was great, but it's also hard at the beginning to find the right people. I mean, that's the big question, no matter what you do in business, is who is the right person to speak to. We've contacted a lot of times some companies, and it was just the wrong person to speak to. And sometimes you just want to you need to speak to the right person who's going to be able to give you accurate information and the right information for exactly what you need. I think that's absolutely something that I might do differently. It's not surprising, we're scientists and we're not trained in business. And so that was really, the thing and I still keep on learning today. I think I will keep on learning for a long time, but yeah.
I mean, you make the point. You're a scientist. Yash is a scientist. You are the CEO. Yash, I think it's the CTO, isn't he? Yash. I mean, when the business starts to build, there'll be more and more focus on business building. Yeah. Are you prepared to kind of move further and further away from the science and more into the business management? Or do you think there might be a time in, a couple of years' time when you say, well, okay, I really want to get back into the tech, and maybe now's the time we bring in a sort of professional CEO to lead the business? Do you have any sort of feelings about that now?
I think so. First of all, for this whole business development, that's why it's really important for us to raise, because we are going to be hiring a CFO. Who is going to
be finance guy.
Yeah. Who's going to be, very important for the development of our company in terms of looking at the numbers, understanding, what is the best business strategy for us, et cetera.
Yeah.
So that's really important. In terms of getting support as well, getting the right advisors. We have two advisors, one who's a partner of a VC and another one who has 27 plus years at ARM in commercial licensing. So that's definitely going to help us on sort of like the sales side of things. We started the company in 2022. It's been 4 years now, and I've sort of had this this kind of
ordeal by fire.
Yeah, a little bit. Yeah. So I actually I really like it. It's in. And of course, I absolutely love the science, and will always be a scientist at heart. But I really find it stimulating to figure out, okay, what's going to be our strategy with this company, right? Or what's going to be our strategy? Where do we see? What are we going to do in the next year in order to get to this particular point? So it's really been something. And I think if I looked at the version of myself in 2022 versus the version today, there's a lot that I know today that I didn't know back then.
Sounds to me, Charles, that you're now becoming a businessman, and that's no bad thing. Look, this has been an absolutely fascinating discussion. I think the technology sounds really, really exciting, and I can only wait to hear the future developments, and hope we'll have the chance to talk about them again. So, Charles Altazura, co-founder, CEO of Metahelios, thank you very much indeed for joining me on the BritChips podcast.
Thank you, Anthony. Appreciate it. Thank you.